You're at a backyard cookout. 6 people, same yard, same night. 20 minutes in, 5 of them are just eating burgers. You're scratching your ankle, then your wrist, then counting 7 welts up your arm. Nobody else has a single bite. You figure it's your blood. Sweet blood. But that's not a thing. There's no evidence mosquitoes can taste sugar levels in human blood, because that's not how blood sugar even works on the surface of your skin. So why is it always you? This is the story of a chemical signal your body has been broadcasting for your entire life. One you've never smelled, never felt, never once been aware of. And for some people, that signal is turned up so loud it drowns out everyone else at the table. Start with how a mosquito finds any human at all, before it ever gets to picking you specifically. Female mosquitoes, only females bite, because they need the protein in blood to develop eggs, run a multi-stage targeting system that starts working from way farther away than you'd think. Stage 1 is carbon dioxide. You've been leaking it out with every breath your whole life, and mosquitoes have been tracking it for over 100 years of recorded science. The sensors on a mosquito's head can pick up your exhaled CO2 from dozens of meters out. Think of it as the dinner bell. It tells her something's out here. It doesn't tell her it's you specifically. Closer in, she switches senses. Thermosensory receptors on her antennae help her tell warm skin apart from the cooler air around it. A 2020 study in the journal Science traced this ability, in the malaria mosquito Anopheles gambii, back to an ancient cold-sensing receptor called IR21A that got repurposed over millions of years into a tool for finding warmth instead of avoiding it. Add in humidity, the faint moisture halo around your skin, and by the time she's a few feet out, she already has a rough shape of human locked in. Now, the part that actually decides who gets picked out of a crowd. That's where a term almost nobody's heard of walks in. Carboxylic acids, compounds your sebum leaks onto your skin, which skin bacteria then break down into the specific odor that makes you smell like you and nobody else. In Aedes aegypti, the mosquito behind yellow fever and dengue, high levels of certain skin-derived carboxylic acids are among the strongest chemical clues researchers have found for why some people stand out. In 2022, a lab at Rockefeller University run by Leslie Vosshall published a 3-year study on exactly this species. 8 volunteers wore nylon stockings on their forearms for 6 hours a day to collect skin odor. One subject, known only as Subject 33, pulled in dramatically more mosquitoes than anyone else, over and over, year after year. The team ran the chemistry and found Subject 33's skin flooded with carboxylic acids, far above the least attractive person in the study, Subject 28. They repeated the whole thing with 56 new volunteers. Subject 33 still won. Case closed, right? Here's the catch. If it were purely a matter of skin chemistry, a new soap or a different diet should have shuffled those results around. It didn't. Attractiveness stayed remarkably constant across years, regardless of diet or skincare. It behaved less like a habit and more like eye color. And the clue to why shows up in a twin study, where researchers compared mosquito appeal between identical twins, who share essentially the same genome, and fraternal twins, who don't. Identical twins matched each other's attractiveness far more closely. Being a mosquito's favorite may be partly written into you before you were even born. Less a habit you built, and more a trait you inherited, the same way you didn't choose your height or your blood type. Mostly fixed doesn't mean completely fixed, though. A few things temporarily turn the signal up. Researchers studying Aedes aegypti found that highly attractive participants, including people in their second trimester of pregnancy, tended to emit more of a compound nicknamed mushroom alcohol. But the researchers were careful to note that no single molecule determines attractiveness on its own. It's the proportions across the entire odor blend that matter, which is exactly why nobody's found a one-ingredient fix. Beer nudges the number 2, though the mechanism is murkier than you'd guess. In a controlled Burkina Faso study, volunteers who drank local beer became more attractive to Anopheles gambii, the mosquito that spreads malaria, than volunteers who drank water. The strange part, the researchers checked exhaled CO2 and body temperature, and neither explained the effect. Something about beer changes body odor itself in a way scientists still can't fully pin down. A separate, looser piece of evidence comes from an observational study at a Netherlands music festival, where roughly 465 attendees who'd had a beer in the past 12 hours were found to be about 1.35 times more attractive to mosquitoes than those who hadn't. It's worth holding that number a little more loosely than the Burkina Faso result. A festival isn't a lab, and dancing, sweating, and whatever cologne someone put on that morning are all mixed in there too. Blood type gets more airtime than almost any other theory here, and it's sitting on the thinnest evidence of the bunch. A handful of small, inconsistent studies have found mosquitoes landing on type O blood somewhat more than type A, but the evidence is small, inconsistent, and far weaker than the evidence for body odor, nowhere near strong enough to explain why you're the one getting eaten alive tonight. Once she's actually landed, there's one more filter. In 2024, a team at Yale led by researcher Bike published findings in Nature showing that mosquitoes taste you before committing to a bite. In lab tests on Aedes albopictus, a mix of salt and specific amino acids in sweat, compounds that did nothing on their own, sharply increased biting when combined in the right ratio. Taste, it turns out, is a second gatekeeper after smell. Skin bacteria play a supporting role too. One study sampling foot odor found that people who were more attractive to Anopheles gambiae had bacterial communities that were more abundant but less diverse. That doesn't fully explain why ankles get hit so hard. Proximity to the ground and thinner, more exposed skin are probably part of that story too. But it does show your microbiome is quietly shaping how you smell to a mosquito. Which brings us to the thing sitting in almost everyone's bag: bug spray. You'd think, given how finely mosquitoes read your chemistry, a thin layer of spray couldn't beat that system. DEET has been used by roughly 200 million people worldwide for over 50 years, and its mechanism has been debated by entomologists for nearly as long. It doesn't work by simply masking your scent the way people assume. One line of research suggests mosquitoes can smell DEET directly and steer away from it, the same way you'd avoid a bad odor. Another suggests it jams specific olfactory receptors, muting some attractive smells while leaving others, like CO2 detection, untouched. Researchers now generally think both are true at once, and that the exact mix depends on the mosquito species. Anopheles, Aedes, and Culex don't all respond to DEET the same way. Either way, the overall chemical picture of a human ends up harder or less appealing for a mosquito to follow. A clinical trial published in the New England Journal of Medicine ranked DEET among the most effective repellents tested, well ahead of folk remedies like rubbing garlic on your skin, which carry close to no evidence behind them. And this might be the part that feels like relief rather than a diagnosis. Since most of this comes down to genetics and baseline chemistry, it was never a verdict on your hygiene. You're not dirtier than anyone else at that table. Your body's just running a slightly different formula, one you didn't choose and can't fully wash away. One useful way to picture the whole process is as overlapping layers, roughly in the order she experiences them. Carbon dioxide calls her over from a distance. Warmth and humidity narrow her in. Skin odor decides whether you specifically stand out, and taste makes the final call once she's landed. The exact weighting shifts from species to species. What drives an Aedes aegypti isn't identical to what drives the Anopheles that carries malaria, but the general shape holds across nearly all of them. Back at the cookout, you're not unlucky compared to the other 5 people at that table, and you're not sweeter either. Right now, your skin is a floodlit signal tower standing next to 5 much dimmer ones. And to the mosquito circling the edge of the yard, that was never really a choice. It was just the easiest math she did all night.